Hi everyone, I am Dr. Vijay Kumar. I am a researcher 5 in Professor Tretiakova lab. I am working on synthesis of deoxyguanosine based formamidopyrimidine adducts. So the whole concept of this project is to synthesize the formamidopyrimidine adducts. It's an 8-step synthesis. We start with deoxyguanosine. First, take deoxyguanosine, then we have to protect the sugar with a clamp reagent. Then once you protect the sugar, in the next step we do an alkylation reaction by using 1,3-butadiene diepoxide using DCM and difluoroethanol as a solvent. This reaction is carried out at room temperature for 3 days. After 3 days I got a product. So the obtained and alkylated product was well characterized using mass spectroscopy and proton NMR and C13 NMR. So once we confirm an alkylated adducts, we have to do preparation of FAPI adduct. So today I'm going to show you how we carry out the organic synthesis in the lab by taking this example. So before you start any organic reactions, first we have to make sure on lab safety. We have to wear gloves, goggles and lab coats. So that is the initial safety thing we should always keep in mind while you work in organic synthesis lab. So today I'm going to show you how to carry out an organic synthesis. Take 25 ml dry 2-neck RB flask charged with a stir bar and close the neck using RB rubber septum and clamp it. So once the RB flask got set up, I am adding an alkylated product which is obtained from the second step. Make sure to close the rubber septa very tightly. Generally in our lab we use Slunkline to carry out moisture sensitive reactions, but today I'm using a balloon filled with argon gas. First, fill the balloon with the argon gas. Insert the balloon to one side of the neck of RB flask, and the other side we insert a needle to expel the air presence in the RB flask. The argon gas should flush for at least 5 minutes, then take out the vent. So in the flask now we have an alkylated monoepoxide product in argon atmosphere. To this I am going to treat with a base. So I am using 1 molar sodium hydroxide in 80% of trifluoroethanol. I am going to add 8 ml of this mixture. Drop by drop. So after adding the entire solvent, the reaction mixture was allowed to go on for 30 minutes. The progress of the reaction will be monitored using thin layer chromatography techniques, that is TLC. To check the TLC, we should make sure the materials and operator as follows. Here I have TLC solvent chamber, graduate cylinder, and silica coated TLC plates which is commercially available, and a TLC spotter, Eppendorf tubes, syringe with a long needle. Take a tiny amount of starting material in the Eppendorf tube. Dissolve in small amount of DCM. This will consider as a starting material for the TLC, and also in another Eppendorf tube, a small liquid of reaction mixture will be taken using the needle. So now I am going to spot TLC using starting material and the reaction mixture. Make sure you spot the compounds about 0.5 centimeter of space on the either side of the TLC, and make sure you spot the TLC in straight. Next, I'm going to prepare the mobile phase today. I'm using 5% methanol in DCM. Pour this mobile phase into a solvent chamber. And allow to run TLC. Once the TLC run all the way up to 90%, the TLC plate was taken out from the chamber. It's gonna monitor under UV light. So this is how the TLC looks like. We can see the starting material spot where it is a streak, and the other side we could see the product spot which moved a little lower than the reference, where we could see the change in the retention time. So this confirms the reaction happened and we have a product. The reaction is clean and the amount of byproducts is negligible. If we have multiple spots in the reaction mixture, we should do separation using column chromatography technique. But in my case, since I got a single spot, I am not going to purify it using column chromatography technique.